Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, March 25, 2022. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you on a cool spring evening in my hometown of Rockport, Massachusetts. These Earth and Space Reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our life-sustaining environment, and who wonder about the greater cosmos, including our place in space and moment in time. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. They are also in regular rotation on the 1623 Studios Community Access Cable Television channel. I am grateful for the continuing interest and support shown by Rockport educators and students, Cape Ann cultural colleagues, cohorts of the Gloucester Area Astronomy Club, sundry science and education associates, far-flung friends, family, and other curious folks. Thank you for participating. This evening, I am pleased to be hosting Steve Durst, founder and director of the International Lunar Observatory Association, or ILOA. Based in Hawaii, Steve and his team run the ILOA Galaxy Forum program of lunar missions and symposia dedicated to advancing astronomy from the moon, 21st century space science education, and the prospect of returning humans to the moon within the decade, the first giant step toward the stars and Milky Way galaxy. Steve also is editor and publisher at the Space Age Publishing Company, which has been running since 1976 from offices in Hawaii and California. Space Age publishes a weekly space calendar and the Lunar Enterprise Daily. It also supports pioneering enterprises such as ILOA, Stanford on the Moon, and Ad Astra Kansas initiatives. Steve comes to these space-oriented enterprises with a unique background in the humanities, having received a BA in European history and an MA in American history from Stanford University in California. So we are grateful that you could interrupt your lunch hour in Hawaii to regale us on doing astronomy from the moon. The Zoom platform is all yours.
Okay, well, thank you very much, Bill, for the kind and informative introduction. And aloha from our island to yours. And I'm very happy to share some of our perceptions and projects and update you on our interesting work, and having heard a little bit about Bill's and your interests there. So thank you very much to the Earth and Space Association, or associates gathered there in Rockport, or at least connected to Rockport with Bill. So the presentation will be, as Bill suggested, astronomy from the moon and the International Lunar Observatory Association 5 moon missions. I also have added on some slides surveying major international space and astronomy programs around the world. And if we have time, we'll get to that. I understand that we're talking about a 45-minute window. Is that right, Bill, with some questions at the end? So
yes,
I'll try and proceed and see if I have enough time and air to fill that window. Okay, as I said, we're the International Lunar Observatory Association, based here in the 50th Aloha State, pretty close to the center of the Pacific Hemisphere, actually. So international fits very well with our location and interests. Astronomy from the moon, and why we are interested and so dedicated to doing that. There are some things that some observations, as noted, that are feasible only from the moon. The first and very frequently noted advantage of the moon for observation for astronomy is the far side, which offers radio quiet environment being shielded from Earth radiations and transmissions by the moon itself. And there have been many interests since the beginning of modern astronomy from the moon research, which coincides pretty much exactly with the dawn of the Apollo moon program in the 1960s. That's when astronomers and scientists first began conjecturing, well, once we're at the moon, what do we do? And obviously looking up is, on any exploration, one posts a lookout. So it seems like a natural, almost no-brainer. And I do think that as the human return to the moon on a permanent basis goal is now underway, significantly underway, astronomy will be one of the very first widespread functions, I believe, on the moon. So besides the advantage for radio astronomy on the far side of the moon, there are efforts underway, by the way, at very prominent international organizations and space organizations to designate the far side of the moon, at least part of it, perhaps the center of the far side, as a protected radiation zone, free from radiation. And that would mean making sure that there are no activities that would generate radiation or communicate. No cell phones on the far side of the moon. We'll see how far that goes. The third bullet point is perhaps most widely recognized advantage of the moon, that it's of almost non-existent atmosphere. So all the efforts on Earth to accommodate local storms and clouds, and of course the always present water vapor, whether down at sea level or even up on Mauna Kea at 4,200 meters, there's still water vapor that needs to be compensated and mitigated. Of course, we have the adaptive optics on Mauna Kea and elsewhere that help mitigate that interference from water vapor. But on the moon, there's considerably less than at 4,200 meters. In fact, not very well known is that there's even less water vapor exosphere on the moon than there is in Leo. So the moon may offer even superior optical observation qualities than some of the observatories in low Earth orbit. We're not talking about the new Webb telescope way out in L2, but which has as thin an exosphere as the moon, but Leo has considerably thicker exosphere. The very stable platform that is the moon offers opportunity for interferometry, for long duration observation. And finally, as I say, as humanity, not just the USA, but the major spacefaring powers are preparing for a return on a permanent basis to the moon, the access to service and develop and expand and construct astronomical facilities is considerably easier and less expensive than they will be in space. So those are some, but not all, of these significant advantages of using Earth's natural satellite for a new frontier of astronomy. And that's what we are looking at with our mission, really a new frontier of astronomy, not necessarily the best, although it could be, but after Earth and space, which is we've been operating astronomical observatories from space for over 50 years. So as valuable as it is, it's not new compared to the astronomy that will be done on the moon. And this is a inspiring graphic from a close associate, Dr. David Shrunk, an MD, as well as an aerospace engineer, and several of his colleagues wrote a book on the moon at the end of last century and promoted the great advantages of astronomy from the moon. And there's a very simple, but again, profoundly motivating image, schematic drawing of the global placement of telescopes and observatories that are possible and likely to happen on the moon, just like here on Earth. Wherever there's a gathering of human civilization, there are observatories, and we can expect the same on the moon. And any place on the moon affords a lookout into the cosmos, into the universe, with infinite number of objects for observation, and many different kinds of targets and functions. I think we're getting a little feedback here.
We're getting some feedback.
Many different kinds of targets and functions. That may be better. Okay.
Yep,
Thank you.
If everybody could mute themselves. Thank you.
Okay, well, thank you. So we're looking at the prospect of a new frontier of astronomy, global placement of telescopes and observatories on the moon as the development of the moon and the entire cislunar Earth-Moon system proceeds. And again, just a quick listing of some of the more salient objects for observation from the solar system objects, Earth approaching objects that might not be detected from Earth because of various reasons, such as the coming from the sun and making them not visible easily, search for extraterrestrial life, and many advanced astrophysical researches. The brief, one way of approaching this is to look at what has been done and what is proceeding in terms of astronomy from the moon. And you can see from the slide there a variety of astronomical facilities and instruments going back more than 50 years. The first Soviet moon rover called Lunar-1 conducted X-ray observations. Shortly after, Apollo 16, that was commanded by John Young, Captain John Young. We'll see an image of him later, but the image at the top row in the center, that gold yellow looking far UV spectrograph, which sits on the moon right now, it was left there by the Apollo 16 mission, and did conduct, I think, the first observations, human-tended observations ever from the moon. Something like 180 images of the cosmos were obtained with the UV camera. And I should say that John Young, Commander Young, was a founding emeritus director, honorary director of ILOA, and for a number of years during our board meetings, he would open the meetings with some comments about, well, the moon is a great place to do astronomy, and he was there. We, by the way, also our organization awarded John Young with the Astronaut of the Century Award. And there's a good argument that he was the most accomplished astronaut of the 20th century. Seven space missions, including 7 missions into space, including one from the moon. He went to the moon twice, once around and once on it. Moving on, the next actual astronomy from the moon was done 8 years ago, going on 9, by the Lunar Ultraviolet telescope that still sits on the the China Chang'e 3 lander, the first spacecraft to land on the moon in 40-something years, occurred, as I say, about 8 years ago. ILOA has had a long established MOU with the Chinese astronomers at the NAOC, the National Astronomical Observatories. And we were able to participate in mostly indirect ways with LUT observations. And I'll show you a little later that we obtained, with collaborating with astronomers here on Hawaii and in China, in obtaining the first galaxy spiral image, M101, from the moon with that LUT. It sits on the lander on the top left side of it. We are preparing and dealing with life on the launch pad realities of delays in complex and ambitious missions. We were to have launched our ILOX, which I'll have more to say about later. That's our precursor mission, our second precursor mission, because the first, as I just mentioned, was collaborating with the LUT. And the second is all ours. We call it the ILOX, set to launch now no earlier than June. And we're ready. We've done many preparations, many experiments, many files to upload and be transported to the moon as early as June. And again, I'll tell you more details about ILOX and how it came to be and what we're doing there. At the same time, we share payload space with a University of Colorado radio astronomy experiment with the acronym ROLSIS. I can't recall its full, the acronym name, all the words now, but it will be determining electron radiation measurements on the near side surface. The PI is one of the very veterans of this astronomy from the moon pursuit, Dr. Jack Burns. And we had a telecon with ROLSIS and Jack Burns that NASA arranged last week to see how we could help each other with our instruments. There are about 12 payloads going up on the ILOX mission that will be carried by the Intuitive Machines spacecraft called Nova-C. Again, more details later. And that's to be launched by SpaceX when everything is ready. And those are our near side observatories, past and present and future. The far side, again, there have only been 3 successful landings on the moon since the 1970s, when Americans and Soviet Russians landed on the moon. And all 3 of those were large, I call it Toyota-sized landers that the Chinese successfully landed. Chang'e 4 was the first to land on the far side of the moon, and that that's ongoing for very low frequency observations in conjunction with Netherlands, with the Radboud University in the Netherlands. It's called the Netherlands China Low Frequency Explorer, and it's been operational for going on for 3 years now, going on 4.
You like this?
The far side, as I mentioned earlier, is a great area of interest and attraction for astronomers seeking radio-free silence.
Hey, please. We did. Oh, we're not muted.
And that far side mission, it's mid 2020s. Jack Burns, who's Rolls experiment, as I just mentioned, is going up with our ILOX later this year. Jack Burns has several missions planned for far side observation. The folks interested in Mars and going to Mars like the idea of far side also, that you can't see Earth, and it puts you out there, cuts you off a bit attitudinally. But again, the far side has been considered as an ideal location for VLF, for very low frequency, long duration observation of the earliest star formations for off and on these past 60 years, since the beginning of the Apollo program. There was a key study done about 30 years ago by a professor named Dr. Wendell Mendel, nicknamed the Man in the Moon. He did a study for the International Space University on far side observatory and science station. At the South Pole, which for those of you not looking at lunar matters too much, the South Pole has become, in the past 20 to 30 years, the worldwide consensus choice of scientists and explorers and engineers because of all the rich assets at the South Pole. That's where the first human settlements probably will be planted and will be attempted. That's where the USA returned to the moon commitment to land the first woman, and the next man is focusing on at the South Pole of the moon. And it turns out that this year, which could well become a year of the moon in many ways, since there are 10 missions now that are planned this year for the moon. As we know from experience, as they say, life on the launch pad and a lot of delays. I doubt all 10 will go, but hopefully a few, including one that we were keenly interested in and just about ready to outreach to until the activities of a month ago from Russia led us to drop that interest and pursuit for now. And we haven't heard any news about what will be a real flagship for the Russian space program, at least as of a month ago, and who knows what the future will be. Although, as you probably know, there are 4 Russians now working with 4 Americans and a European on the International Space Station. 3 Russians just arrived there 2 days ago. But Luna 25 shows persistence, because Luna 24, the last time the Russians landed on the moon, was 1976. Luna 25 is the follow-on. It's been a long time. And I think from a space technology point of view, a lot of the prospects of the Russian space program in this decade will rest on the success of that mission, if it still is on track. Been many, many years, as I mentioned, decades in preparation. About the same time, and going very similarly to a similar location, near but not at the South Pole region, about 70 degrees south, so some distance still from the true South Pole, will be a spacecraft lander from India's space agency called ISRO, ISRO. ISRO attempted to land its first lander, Chandrayaan-2, about 3 years ago and got very close, and failed in the last few hundred meters, and it crashed. They picked themselves up, dusted themselves off, and will be pursuing Chandrayaan-3 to about the same location as the Russian Luna 25, middle of this year. And then our flagship, the ILOA flagship called ILOA1, is aiming for a high mountain. More about that shortly. A high mountain about 5,000 meters tall, taller than Mauna Kea here, for our flagship ILO1 mission. And we're still looking for a ride, basically. Anybody has any suggestions, please let us know. We are taking robust initiatives to generate a ride, to find one. And one of the neat things about the moon is once you're on your way, it's only 3 days travel, and that's by 1960s technology. So I think that the level of activity that we're going to see this decade in particular will be quite dramatically enhanced compared to what we might see from regarding Mars, at least this decade, because of the distance. Again, on average, the moon is 500 times closer to us than Mars. And then the North Pole, there was a mission that was slated for the North Pole from Carnegie Mellon University, but it's been canceled for now. But no doubt there will be observatories, North Pole, South Pole, near side, far side, and all around the moon, as we saw in that graphic earlier. Well, I better speed up a bit. Types of observation. On the near side, most all of the observations, certainly optical also, which is listed. Far side radio, and the cold traps and the cold of the far side provides great opportunities for infrared. I mentioned the VLF and long duration applications. Most locations, optical, gamma ray, X-ray, and interferometry, and more speculative and ambitious astronomical projects include the possibility of Earth-Moon VLBI, that would be a very long baseline indeed, and the Event Horizon Telescope participation. Our ILOA and the talk here that Dr. Waller and I, that Bill and I agreed on, will deal with a snapshot of what our organization is doing. And the mission, like many astronomical missions, to expand human understanding of the cosmos, but this time through observation from our moon. We've been a nonprofit since 2007 here on Hawaii Island, the big island of Hawaii. Our closest neighbor, both physically and attitudinally, is the Canada-France-Hawaii telescope, one of the world's premier telescopes. Their headquarters is about 10 meters away from where I sit. And we're in the north central part of the big island, as I mentioned, about less than an hour's drive to the 4,200 meter summit observatories. The significant characteristics of ILO, of the ILO, of our ILO1 in particular, is its multifunction, most particularly observation and communication. It will have some power generation considerations and capabilities, and participate in the human build out, whereas I mentioned the South Pole is the most likely, almost certain first destination for human sustained activity. And our commitment with ILOA is towards galaxy imaging and astronomy from the moon, and in the process generating a first light industry, which is works on 2 or 3 different levels, that concept of a first light industry. So I say, I think there'll be a lot of construction of instruments and facilities on the moon astronomically. Besides an active day-to-day active executive committee right here in this office, there are 27 distinguished directors internationally, including I think 3 astronauts there. And Commander Young is not pictured since he's no longer with us, but we'll be putting his name and the names of other former colleagues on the moon with our ILOX. 5 moon missions. We've talked about, and well, I mentioned the precursor on the lower left, our first mission to the moon, small as it is, and it's very small, but we're lucky to be aboard the Intuitive Machines spacecraft. After the ILOX, we are attempting to land the ILO1 at Malapert Mountain, as you see in the top right. That's our vision painting showing our human servicing mission, which is referenced on the bottom right, our 5th mission, which we hope to align this human service mission with what's going on right now with the Artemis mission. The Artemis, first woman on the moon, return to the moon. NASA's mega moon rocket, NASA calls it, is sitting on the launch pad at Kennedy Space Center on pre-launch checkout right now. It's still about a month away from launch, maybe 2. But ILO1, that's an image of it, and it's being serviced by timeshare astronauts, or however we can arrange, taking first light of the Milky Way galaxy, and some comment about the significance of that image, the first image of the Milky Way ever from the moon, and transmitting that information back to Earth, and then succeeding with a variety of other astronomical observations. The ILO2, the backup, its location will be decided by where ILO1 goes, either also to Malapert Mountain or perhaps to Shackleton Rim, where NASA's Artemis astronauts may well land at Shackleton Rim. Shackleton crater sits exactly on the south pole of the moon, named after the pioneering Antarctica explorer. By the way, in the space and moon community, the moon is frequently referred to as the 8th continent, which in lots of ways it is, proceeding from the 7th continent. And I think there are a lot of lessons to be learned in that analogy. And you see in the bottom center image there, the Chang'e 3, which while the power source on that lander is rated for 30 years, the instrumentation was turned off so as not to interfere with the sensitive radio observations of Chang'e 4, at least while it was landing. And finally, our artist did a graphic of first women on the moon. And we ran a poll that's still open on our website, as asking readers to express their opinion as to which country or enterprise would put the first woman on the moon. I think the poll numbers, not surprisingly, came out to USA first. I think either other enterprise or China was second. But do take a look at our Space Age Publishing Company website, and you'll see the poll, and you can cast your vote there. Going through some of the more detail on our precursor mission, here's the LUT. I mentioned we imaged the first galaxy spiral ever from the moon on the top left. The LUT did. It's a 15-centimeter instrument, by the way, quite small, but precursor proof of concept. There's the image, first one that our Hawaii astronomers worked with the China astronomers on obtaining that, and I think late December 2014, so it made a great New Year's present. And the control image on the right showing that's the galaxy in question. The instrument, you can see on the right-hand top of the screen. The MOU agreement was signed right here in this building in the next office over by ILOA and NAOC astronomers in 2012. That's the imaging team of the China team down below with PI Professor Jinyan Wei. The ILOX, a Canadian company in keeping with our international nature and mission. International is our first name, of course. In Toronto, Canada, the Canadensis Aerospace Company developed the instruments and is working to finalize and make flight ready the payload with Intuitive Machines, the spacecraft provider located in Houston, Texas, and to be launched, as you can see, by a SpaceX Falcon 9. The delay is not coming on the SpaceX side, but on the lander development side. Again, three or 4 days travel to the moon, I guess, is a day in orbit, both around both worlds, both bodies around Earth before translunar and then around the moon. Our attempt to get the first image of the Milky Way galaxy with our first light. We've invited a number of prominent astronomers from observatories all around the world to make invited observations with our first instrument. They're very small, but they're proof of concept to validate these technologies. And there's some of the observational locations that we're working on these invited observations. We'll also be sending up some files of our affiliated organization, Space Age Publishing Company, that Bill Waller mentioned in his introduction, that we operate a Space Age Publishing Company, a weekly that I highly recommend. Those of you interested in space and astronomy, it's more astronautics and astrophysics, but plenty of astronomy. Space Calendar Weekly, and we intend to broadcast that from the moon for scientific, educational, and commercial reasons. And we are, again, preparing horizontally, I like to say, rather than preparing vertically with a countdown to launch. Although we do have a countdown, it's still tentative to June 1. But we're preparing other experiments, to exchange observational data with other payload developers. You can see the image, the instrument on the right. The total mass, we have two instruments, a wide field and a narrow field imager. There's some of the specs of each of them. The total payload is 0.6 kilos, which is very good because it's very expensive traveling to the moon. But 0.6, we have a manageable price tag on our two small instruments going to the moon. No comparison, of course, to the Webb telescope, but ours may be serviceable. It'll be a short window of operation. It's not designed, the instrument or the lander, to survive the 14-day cycle of the lunar day. There are some attempts to extend that lunar day by a few hours or maybe a day. There you can see in the image the two instruments sitting atop. They're fixed also. Again, this is a low-cost mission, and there's no steerability, no mobility of the cameras. But so we'll just have to take what the spin of the moon gives us to the celestial sphere. And the objectives, again, galaxy first light imaging, astronomy, then we'll turn the instruments down for Earth observation, long duration, for a growing number of very useful, valuable Earth observations from the moon. Every form of navigation and transportation and communications depends on precise values of Earth rotational speed, including astrophysical observations and those dealing with precession and Earth axial precession. And then we'll continue to pan the ILO1, which will be steerable and movable, unlike ILOX. ILO1 and 2 will be advanced technology capabilities. Continue to pan tilt the instrument down for lunar surface for help characterizing the local lunar environment. Additional applications, again, any observation one can think of are available from this new frontier of astronomy. The South Pole, as I mentioned, it's asset rich. That particular location, Malapert Mountain, gives us power on about 80% of the time, so we won't have to shut down or carry a nuclear power source. We'll rely on the sun 80% of the time. 24/7 line of sight for observation and communications with Earth, extremely valuable in many ways. We're near the ice water trap, so there will be a lot of activity at the foot of Malapert Mountain, where these cold traps holding ice water are located. The big Aitken Basin, one of the largest basins, impact craters in the solar system, about 2,500 kilometers across, is a treasure trove for geological assets, and certainly there have been many discussions already, not by us, but of mining possibilities. The southern skies, rich astronomically. Antarctica provides a South Pole analog. I mentioned we're going to the South Pole. We humans have experience on more experience at our South Pole than the North Pole. 5,000 people now at the South Pole, mostly scientists, 1,000 year round. And again, a lot of lunar South Pole developments that will provide the need for observations and communications. Galaxy first light imaging, we hope will have the same impact attitudinally that the first image of Earth ever from the moon did last century. This time in the 21st century, when we go back to the moon, we look not just back at our home planet, and you know the impact that image had in the 20th century, the entire environmental, ecological awareness and movement. We will look out towards this other great iconic object, the center of our Milky Way galaxy, out towards our future. And that's what we hope will, to me, the focusing and learning about the galaxy is the most important object of study and interest in the 21st century. And I think it extends beyond physics and astronomy as well, the importance of understanding the galaxy and its significance. We've conducted, as Bill mentioned earlier, a Galaxy Forum program. Have now conducted more than 105 such Galaxy Forums, all the way around Hawaii, across the USA, and globally, those being some of the locations. And sure, at some time we'd like to have a Galaxy Forum from Antarctica and eventually on the moon. This galaxy map that my colleague Elisa Perednia produced is a real popular, became so popular that astronomers suggested and others that we laminate it, and we did. So now people can eat while they learn. And the obverse side has a wealth of astronomical data and information. I mentioned, and I won't have time now to go into detail about our work on aligning with the first woman on the moon, maybe to service some of the robotic observatories that will be there at this time. I have a video, but I'm not sure that there's time to show it, Bill. If there is, I can come back to it. It's about 3 or 4 minutes that we produced regarding the ILO1 mission.
I think you're okay. If you're pretty much near the end.
Well, I am, but I did want to go over a few slides real quick just to show you that we are very international in our outreach and astronomical work. Here's a look of the countries that we work in. This shows a lot of the Southeast Asia countries, the principal slide in the center. I mentioned John Young, and there you see him top left, and then on the bottom landing site, and you can see the UV camera that was left there. And now we're aligning with the return of humans to the moon. That image on the top right is of Earth that was taken with the UV camera by Commander Young in 1972. China on the moon, again, multiple activities, and they're developing their human return, perhaps a few years after the projected American return, which is now projected to be around 2025, 2026. India, where we have very active interaction. The former ISRO chair, Professor Rao, was a founding member of ILOA also. You see his image in the center. There's been an expression of astronomy from the moon from the very significant complex of India national observatories. And they are preparing their Chandrayaan-3, as I mentioned earlier. Japan has 2 missions to the moon this year, 2 landing missions, and also has interest in astronomy from the moon, less well developed, I think, than some of the other countries, which is a little surprising, but we can expect to see a lot of innovation, including astrophysically, from Japan and other countries as well. Korea has an orbiter this year. Russia, we mentioned. Europe has yet to land a spacecraft on the moon. Canada has ambitious moon program today. And that is my presentation, and wishing you all aloha and inviting you all to get in touch with us should you come this way. And now, Bill, your choice on how we spend whatever time is remaining, whether you have questions or you'd like to see the 3 or 4 minute video, it's up to you.
Well, why don't we get the folks to ask their questions first, and we'll see how far we get to go.
Sounds good.
So folks who speak, don't forget to unmute yourself.
Lisa, do I have to do anything? Oh, sorry. Okay, thank you.
All right, so I know there was a question early on in the chat, and it was I think it was Paul Geary about how one deals with the power on the far side of the moon. I did note that there aren't any major missions to the far side of the moon coming up, and your missions are all on the near side or at the pole.
Bill, I was actually talking about if you do radio astronomy on the far side and you have this need for absolute radio quiet, how will I get data back from the far side?
Yeah. Right.
Well, by orbiters providing a relay. China already has an orbiter providing relay for their lander, and that does raise a good question, though, of being able to maintain electronic quiet by the orbiters as they orbit. So that's one way, and another way, there may be alternate power cells that are under development, new technologies. The China lander, just like the Apollo landers from the 60s, contains an small handheld RTU units, radiothermal units, as do our Mars landers and the Saturn and Jupiter missions. And that is what is operating the Chang'e 4 right now, is a radiothermal energy.
And by that, you're dealing with a little bit of radioactive substance, right?
You are. One is. That's right. raised a lot of controversy for obvious reasons. It's proved safe so far. Our mission, of course, is solar mission, and we're not dealing with that. But all of the NASA and other countries who do deep space missions, Mars, Jupiter, Saturn, and the New Horizons to Pluto, use RTG, radioactive thermoelectric generator, or as Alan Stern, the principal investigator of the New Horizons mission that went to Pluto, he said that's the only way they could have made it to Pluto with an RTG, which he called a really terrific generator. That's what Alan did. But it has its uses perhaps, but that's another matter not for us here to deal with. We're not dealing with any RT matter.
I have a question from Eleanor Harris, and it kind of builds on why the International Space Station has been a success, because it's a geopolitical success story of cooperation. She asks, will international research collaboration translate into peaceful development of settlements and commercial and military enterprise?
Yeah, well, that really is the question, isn't it? And I wouldn't necessarily equate commercial and military, but personally, I think that was the most important accomplishment for my own sense and values of the Apollo mission, was the plaque that was left on the moon by Neil Armstrong and Buzz Aldrin, that we came in peace for all. Man. And I do think that the moon has intrinsic benevolent forces that humanity may have a chance to get its act together there. Like I see the moon as sort of humanity's sandbox in the backyard, where we all learn to work and play together before we go out into the big depths of space, like Mars and Jupiter and beyond. So I think that is the question, and the UN 1967 treaty, the Outer Space Treaty, also affirms the predominant peaceful use of space resources as being most important. And I think there's reason for optimism in one word, and that is Antarctica. The seventh continent may hold lessons for the eighth continent. The Antarctica Treaty, which went into effect in 1960, with originally 12 and now I think 60 countries, commit to the peaceful and the exclusively peaceful scientific use of Antarctica, of the seventh continent. There are some 30 countries maintain dozens of research stations, including some of them year-round. Military activities are prohibited, so are commercial ones, which is another matter for the moon, perhaps. But that is an example of successful use of the seventh continent, also nicknamed the science continent. And I think that is my one-word answer to how we develop the moon and keep it peaceful and scientific. Antarctica.
Bill?
Yes, Michael.
I just had one, I hope, really quick question. We're getting really good at putting telescopes into space in orbit around the Earth. What's your value proposition for astronomy that makes it worth the risk of landing things on the moon?
Well,
why is it, what can astronomy do on the moon that it couldn't do at less risk or less cost in orbit? I don't know the answer to that, but it seems an obvious question.
Well, Michael, I did mention at the start of the talk, there are some advantages on the moon that space doesn't have. The stable platform allowing interferometry. We won't go to the moon to do just astronomy, but once we go to the moon, it's one of the more obvious and easiest things to do. Just like any expedition, one of the first things that an expeditionary mission will do is to post a lookout and build a fire and put up a tent. It's just a natural function. So as we go back, and we are going for a variety of reasons that have to do with energy, with material, with just the human spirit of growth and exploration, observation will become inevitably a natural function. So again, the costs of going to the moon are not being borne by astronomers. They'll hitch a ride. And as we're doing with the intuitive machines, we're just fastening ourselves to the top of the lander. And I think that another advantage is once there's human activity on the moon, human settlement, servicing of these instruments that can be built, with 1/6 gravity, and that should be added to that list of what you can do on the moon that you can't do on Earth. 1/6 gravity will permit 100-meter observatories. I've always been interested about the history of refractor astronomy. How they got bigger and bigger through the 19th century, and then I think the one Lick Observatory was just under 1 meter, and then the biggest refractor is at Yerkes Observatory in Wisconsin, just over 1 meter, and that reached a limit because of gravity distorted the mass of the lens. So no refractors were ever built larger than 1 meter, and of course reflector technology superseded refractor technology. With 1/6 gravity, I wonder, it should be possible to construct a 2-meter refractor or larger. And I think many the materials are there for construction. Most of them, all of the silicon, aluminum in mass. So I think the prospects are very good for a whole new dimension, a whole new era of astronomy from the moon.
Okay, thank you.
Pleasure.
Yeah, I was wondering if I might say something. I wanted to make a comment on sort of that dovetails with your description of the 7th continent as a science continent. Because I was thinking that the moon would be a great place to do all kinds of different experiments and different sciences. You could have, in addition to the optical telescopes, you could have gravitational wave detectors, particle accelerators, seismometers, and doing different kinds of geophysics experiments, although I guess you call it selenophysics on the moon. Chemistry labs, biology labs, that could be a really great science environment. So you have these different scientists in different areas that would be interacting with each other to some level, which could lead to some interesting ideas on doing science and supporting each other. I was wondering what you can tell us about other ideas about how the moon is going to be used.
Well, you're right about the wide variety of interdisciplinary sciences that will be engaged. In fact, most scientists, most lunar scientists, at least by a ratio of 10 to 1, probably closer to 50 to 1, are geologists and not astronomers at this point. And the range of their experiments is always growing. And again, you're right that all of it's a whole new world, literally, that has different metrics. The mass, the 1/6 gravity is bound to affect every aspect of science and human endeavors and operation. And I think you're absolutely right that it's going to be a very exciting frontier that opens up for biology, for geology, for astrometry, astronautics, astrophysics, and etc.
Right.
We just need to get there. And my big question is why the USA, either the government or the very robust private enterprise independent sector, has not attempted a single spacecraft landing on the moon in 50 years this year. And I have some ideas, but maybe because it is so profound a change that will be brought.
You could also, there's a historical precedent for that in the sense of Antarctica that was explored a lot in the early 20th century, but it wasn't really developed as a habitat or a colony until like 50 years later. So there seems to be like a 50-year lag for these things. So it's happening with the moon as well, which seems to be like a standard way that the civilization works for humans.
Yeah, I think you're exactly right with that analogy, the 50 years. And you might remember in the early 20th century, one of the most exciting things going on in Europe was the race to Antarctica. It was like front page news in England and Holland and Scandinavia and Germany for years, until it was finally won by Amundsen. Shackleton came very closely. And yes, nobody went back for 50 years. Nobody went back for 50 years. And then in the UN IGY geophysical year in 1957, there was a return to Antarctica. And now there are 5,000 people a year living there, 50,000 a year that go there as tourists. And I think the same thing will happen to the moon. That's right, in this perhaps similar time frame.
Well, I think we should wrap this up. Steve, the video, do you have that on your website?
Yeah, we do, Bill. And if I can figure out how to get it back up, share screen, I guess.
Okay.
To our website.
And
Pardon?
They can go to our website. He's not saying.
we could just go to your website for that.
Okay, great.
All right.
Sure.
Well,
Sure.
this was a very stimulating presentation, Steve, on a whole new world and what we can do with it, especially with that on the astronomical angle, which is 1/50th of the geology angle. So we have a lot to look forward to, and I wish you well with your upcoming launch in June.
Well, thank you very much. Mahalo in Hawaiian. Thank you. And look forward to keeping in touch with you on that and other astronomy matters, Bill. And really enjoyed the chance to talk about our work and to meet some of your associates and colleagues on your interesting Earth and Space report group. So nice to touch base with the other side of the country, six hours away. Time
6
zone.
hours away. That's right. Amazing.
Yeah.
Okay,
Well,
thank you, Steve, and thank you to all of you who stuck around for the presentation. I look forward to seeing you again next month.
Thanks, Steve.
Mahalo. Aloha. Thank you.
I love
Hello.
Hawaii.
Thank you.
Aloha.
Aloha. Thank you.